Dear students, today we will discuss about electrochemical series and the application of electrochemical series. First of all, what is electrochemical series? Now, is the arrangement of the elements on the basis of their increasing order of reduction potential or oxidation potential. It may be reduction potential or it may be oxidation potential, or it may be defined as it is a list of elements in which they are arranged in the order of their standard electrode potential on hydrogen scale. Now this list of arrangement of elements which is obtained by arranging the elements in the order of their standard electrode potential is basically called as electrochemical series. Now on the basis of hydrogen scale, what does it mean? Because we cannot measure the electrode potential of a cell individually, we have to compare it with some standard element. So for this purpose, the standard electrode is hydrogen. So hydrogen is also standard electrode and it is also called as standard hydrogen electrode SHE, SHE. We will denote it by capital SHE. Now, according to definition, it is the arrangement of elements in the order of reduction potential or oxidation potential, but there is the recommendation of IUPAC on the electrode potentials. According to the recommendations of IUPAC, the electrode potentials that has been given in the reduction mode in the electrochemical series. So the problem is solved. Now the elements, they are arranged in electrochemical series on the basis of their reduction potential values. Now if we change the mode of the electrode potential, so the magnitude of the electrode potential does not change. That is, the magnitude remains same, but only the sign is reversed. For example, if I take the example of copper, for copper the reduction potential value is 0.34, but if I take it in the form of their oxidation potential values, then it will be minus 0.34. It means copper is originally given in the form of their reduction potential values, which is positive 0.34, but if we change the value into minus 0.34, then it will be the oxidation potential of copper. So only the sign is reversed, the value remain same. Now the question is, that all the elements which lie above standard hydrogen electrode has negative reduction potential and positive oxidation potential. Means hydrogen is taken at the center in all those elements which lie below standard hydrogen electrode, they have positive reduction potential values and negative oxidation potential values. Now if we relate the oxidation and reduction potential, so again they are same values but only with negative or positive sign. The sign is only reversed, rest all the values remain same. That is, I have written down, there is oxidation potential is equal to reduction potential but with a negative sign. Again, if the oxidation potential is taken in negative, so the reduction potential will be positive. Now these are general introductions and general points regarding electrochemical series. Now, what are the applications of electrochemical series? Number first, it is used to predict the feasibility of a chemical reaction. That is, with the help of electrochemical series, it is easy to predict whether a particular reaction will take place or it will not occur. For example, if the electrode potential of a cell is positive, then such reactions are feasible. And if the electrode potential of a cell is negative, then such reactions are not feasible. Let's take the example of copper and zinc. The electrode potential of this cell is equal to the oxidation potential plus reduction potential. The oxidation potential for zinc is 0.76, that is, zinc is going to oxidize, and for copper this is equal to 0.34. and copper is accepting 2 electrons and converting it to copper elemental form. Now, if you find out the electrode potential of this cell, so electrode potential of the cell is equal to 0.76 plus 0.34. The overall value is 1.1 volts. It means that the value is in positive, so this reaction is feasible. Zinc and write down the values for this reaction. Then electrode potential of the cell is equal to, now copper is going to oxidize and zinc is going to reduce. So the oxidation value for copper is now with opposite sign, that is minus 0.34, and for zinc it is now minus 0.76. By adding the two values we will get the value that is minus 1.1 volts. It means the sign is negative, so such type of reaction are not feasible. Now in this case, zinc cannot oxidize copper. The first reaction, copper can oxidize zinc. Now the next application of electrochemical series is the spontaneity. To find out the spontaneity of a chemical reaction, whether a particular reaction will occur spontaneously or it will not occur spontaneously. So general rule, that if the electrode potential of the cell is positive, so such type of reaction will occur spontaneously. And if the cell potential is negative, then such reaction will they will be non-spontaneous reactions. lead and silver. So the electrode potentials are both are added to find out the cell potential, that is oxidation potential plus reduction potential. So in this case the cell potential is equal to the electrode potential of lead plus the electrode potential of silver. Putting the values, we will get that the value for this is 0.13 and for silver it is minus 0.80. So we will obtain the value which is equal to minus 0.93. So again the sign is negative. It means the negative sign shows non-spontaneity of a chemical reaction. Right. Next is if the same reaction which is occurring above, it is reversed. That is, now first we have this reaction. If we reverse the reaction, that is silver and Pb, it goes to Pb plus 2 and 2 silver. Now when the reactions are reversed, so the values are also reversed. So we will write down the values in this way, that the cell potential is now equal to the oxidation potential of silver plus reduction potential of lead. Putting the values 0.80 now with a positive sign, and for silver it is also with positive sign. So we will get the value, that is 0.93, and the 93 is in with a positive value. The positive value means this type of reaction occur spontaneously. Application of electrochemical series is to find out that which element will act as cathode and which is anode. So remember the thing that the electrode which is having less reduction potential will act as anode, and that is which is having higher reduction potential will act as cathode. So I will write down the rule that the element with less reduction potential will always act as anode, and with higher reduction potential values will act as cathode. For example, the reduction potential value for copper is equal to 0.34 volt, and for silver it is equal to 0.80. Now in both the cases the value of copper, this reduction potential value of copper is less, and this value is greater or higher. So copper will act as anode while silver will act as cathode. Application number which element will displace hydrogen from acids. So the element with low reduction potential and higher oxidation potential, they will be able to displace hydrogen from acids. While on the other side, the elements with high reduction potential and less oxidation potential, they cannot displace hydrogen from acids. Now if we take zinc is very less as compared to copper. For zinc the value is minus 0.76 and for copper the reduction potential value is 0.34. So reduction potential value of copper is higher and its oxidation potential is less. If I write down the oxidation potential, it will be minus 0.34, and in case of zinc the oxidation potential is 0.76 volt. As it is discussed that with low reduction potential and with higher oxidation, so oxidation potential of zinc is higher and oxidation potential of copper is less. So zinc can displace hydrogen from acids while copper cannot displace hydrogen from acids. If we write down the reaction of zinc with H2SO4, so it can form zinc sulfate along with the evolution of hydrogen gas. So this type of reaction is possible, it can occur. But if we write down the reaction of copper with H2SO4, so this type of reactions cannot occur and these are not possible, these are wrong reactions, because according to electrochemical series zinc has low reduction potential value and high oxidation potential value, while copper has high reduction potential value and less oxidation potential value. Thus, zinc can displace hydrogen from acids while copper cannot displace hydrogen from acids. Rule number 5 is to find out the relative chemical reactivity of metals. So again, as we have discussed, the first one, that the elements with low reduction potential and higher oxidation potential. Similarly, the same case is here. I will write down in this way that the elements whose reduction potential is less and oxidation potential is higher, they have the tendency to lose electron easily and form positive high, and whose oxidation potential is less, so they have less tendency to lose electron and form positive ions, and whose oxidation potential is greater or higher, they have the tendency to lose electrons easily and positive ions are formed. So those elements which are having these properties, they are much reactive. While on the other side, the elements with high reduction potential and with less oxidation potential, they have less tendency to lose electron, thus they cannot form positive ions easily, so the tendency is less to towards the chemical reaction, so they are less reactive than the first case. So all these are the applications of electrochemical series. That today's lecture was about the electrochemical series and the application of electrochemical series. I hope you must have understood the rules, that what are the applications of electrochemical series and how we can find out the feasibility of a chemical reaction, either the reactivity of the metals or the spontaneity of a chemical reaction, etc. If you like this lecture, so please subscribe my channel for more videos and like the video as well and share it also. Thank you.